Good morning, everyone. My name is Mavani. I am from the Eric Johnson School of Engineering and Computer Science at the University of Texas at Dallas, USA. My colleagues Gurnani and Khandhediya are here with me today, and we are here to present our work on a salient approach for facial soft biometric classification. The tasks are age, gender, and facial expression recognition. We prefer to call it SAF-BAGE. The motivation behind this work is that background in images pose a problem by increasing the intraclass variance and thereby also hinders the classification performance to some extent. By eliminating or reducing the effect of background data, we in some way we believe that it would contribute in increasing the overall classification performance of a model. This is because uh, the background in each image of belonging to the same class are different. So we came up with the idea that why not use visual saliency or attention maps to provide the regions of an image which are naturally dominant to the human being, and we also believe that these intensity maps can be used to reduce the impact of background by reducing the intraclass variance. Our approach is simple. We multiply the weighted actual images with the visual saliency intensity maps, and with this we get an image which is a bit more exposed at the dominant regions of the subject in the frame, as opposed to the background. For the age and gender classification tasks, we fine-tuned the AlexNet model with fivefold cross-validation and data augmentation, um, so that we can have a much larger data that is 4 times as the original one and can increase the performance as much as possible. We report benchmark level accuracy on both the tasks as shown on the screen with much higher accuracy results using the saliency module. For the facial expression recognition task, we have used the EffectNet dataset and the benchmark. The training data size here is very high for the facial expression dataset, and thus data augmentation is not needed. We fine-tune the LXNet module here as well, and we report a benchmark level accuracy in this as well. We can see on this slide that our method with the saliency module reports 67.65% accuracy on the EffectNet dataset, which is benchmark level accuracy. We have also performed a few ablation studies on the work that we have done. The first one is the choice of the classification network. Not just LXNet, we have also trained the VGG16 network and the GailNet, with the VGG16 network being 1.6% better than the LXNet network, and the GailNet also shows a comparable result with slightly less accuracy of 89.8%. The other study that we performed was using different multiplication weighing ratio. We used the 30% weighing ratio as the standard one in our work, but we also tried out 10%, 50%, 70%, and 90% with different results. We can see on this slide that the 30% saliency weighing ratio maximizes the validation accuracy for the task at hand, and the rest of them can be more useful in different other tasks. From the salient multiplied images, we found out that the eyes, nose, and the mouth are the dominant attributes which are useful for the classification. We also used the class activation maps to bolster this, and found out the same results, that eyes, nose, and mouth are actually the dominant attributes according to the class activation maps. So to sum it up, we can say that the visual saliency maps do help improve the classification performance by enhancing the focus on the subject and frame, and it can also be applied to improve the detection task and is open for future extension. Thank you and have a good day.